In this video, we're going to talk about how to solve quadratic inequalities algebraically. So you can graph quadratic inequalities using methods similar to what we used when we were graphing linear inequalities. You'll graph the corresponding quadratic function as though the inequality sign were an equal sign, and then use the sign to determine whether you need a dotted curve or a solid curve. Then you can use a test point to determine which side of the curve to shade. If the test point makes the inequality false, remember you shade away from the point. If the test point makes the inequality true, remember you shade towards the point. And Desmos can actually graph quadratic inequalities for you. So here's an example of a quadratic inequality. We have y is greater than x squared plus 2x plus 1. So you can see we have a dotted line representing the curve, which is y equals x squared plus 2x plus 1. If you plug in the test point 0, 0, you'll notice that it makes this inequality false. So that's why we've shaded the part that is away from 0, 0. So let's look at the graph of this inequality. We have y is less than or equal to x squared plus 3x minus 10. So this has been graphed in Desmos, and here's a screenshot of that. Notice that you see a solid curve because we have a less than or equal to sign. Notice that the region away from 0, 0 has been shaded because if I plug 0, 0 into this inequality, I get 0 is less than or equal to 0 squared plus 3 times 0 minus 10. So that 0 is less than or equal to 0 plus 0 minus 10, which is 0 is less than or equal to negative 10. That is false, so that's why we've shaded outside where there's not including 0, 0. So remember, for solving quadratic equations, we talked about several different methods. As long as our quadratic equation was in standard form, ax squared plus bx plus c equals 0, we could use any of these 6 methods. And remember, we adjusted which method to use depending on the form of the equation. So we can also use these methods to help us solve quadratic inequalities. So when we solve quadratic inequalities and we're doing them algebraically, we're going to start off by making sure our inequality is in standard form. Then we'll solve the inequality as though it were the corresponding equation. And then we'll graph these solutions on a number line. And remember, the inequality sign will tell us whether we need an open circle or a closed circle. And what happens is these points will divide the number line into up to 3 regions. Then we'll pick a test value in each region and plug it into the original inequality. And if the value makes the inequality true, we'll include that region in our solution. We'll finally write our solution as a combination of the regions that make the inequality true, and remember to use the union symbol as needed. So we'll be writing our solutions in interval notation, and I just wanted to remind you of that. Remember, if our endpoints are filled in circles, we use the square bracket with those endpoints. If our endpoints are not included with open circles, we use open parentheses. You can also have mixed intervals, like you can have a square bracket and an open parentheses. Also, remember that in interval notation, if we have 2 separate pieces that are not all connected, we need to use the union symbol to combine the pieces. All right, so let's now solve x squared plus 3x is less than 10. So my first step is going to be to get this into standard form. So what I need to do is I need to subtract 10 from both sides. And when I do that, I'm going to get x squared plus 3x minus 10 is less than 0. Okay, so now we need to work on solving this as though it were the equation x squared plus 3x minus 10 equals 0. So my preferred method to do these is factoring whenever possible. So I'm going to try factoring this, but if you prefer to use like quadratic formula or anything like that, feel free to do so. So we're going to look for factors of negative 10 because here a is 1. So we're looking for factors of negative 10 that have a sum of 3, right? Because this is A, this is B, and this is C. All right, so the factors of 10 are 1 and 10. And let's see, we have 2 and 5. Since 10 is negative, we need a positive and a negative factor. Since 3 is positive, we're going to make all our bigger factors positive. So let's go ahead and do that. So negative 1 plus 10 is 9. Negative 2 plus 5 is 3. So that's the correct pair. So this can turn into x minus 2 times x plus 5 is equal to 0. So now we have 2 separate equations, x minus 2 equals 0 and x plus 5 equals 0. So let's now solve these equations. So here we can add 2 to both sides. And when we do that, we get x equals 2. Over here, we're going to subtract 5 from both sides. And when we do that, we get x equals negative 5. Okay, so now I'm going to take these two solutions and I'm going to go to my number line. Since I have a less than sign, I'm going to put open circles at both of these points. So an open circle at 2, open circle at -5. Notice that this breaks my number line into 3 pieces, right? I have 3 different regions. I have one here, and then one here. I'm going to pick a test value in each region, and it doesn't matter which value you pick as long as it's in that region. Okay, and so I'm going to pick, let's see, let's pick -7. Here, I'm going to pick 0, and then here I'm going to pick 5, okay? And then I'm going to take that original inequality, I'm just going to write it up here so that we remember, x squared plus 3x is less than 10, and I'm going to plug in each of those test values. So my first value that I picked was x equals, let's see, -7. So this is going to become -7 squared plus 3 times -7, and I'm checking whether that's less than 10. -7 squared is 49. 3 times -7, that gives me -21, and that's less than 10. So 49 minus 21 gives me 28, and that is not less than 10, so this is false. So I will not include that region in my solution. Now let's use my next test point. I picked x equals 0, so I have 0 squared plus 3 times 0 is less than 10, which gives me 0 plus 0 is less than 10, so that's 0 less than 10, which is true. Okay, so that means that this region right here in between these two endpoints will be included in my solution. And now let's try the final test point, which is x equals 5. So that gives us 5 squared plus 3 times 5 is less than 10. 5 squared is 25 plus 3 times 5, that's 15, and that's less than 10. 25 plus 15 is 40, so we have 40 is less than 10, which is false. Okay, so we're not going to include that region. So the only region that's going to be included in our solution is this right here between -5 and 2. Remember, in interval notation, that's going to look like this. We're going to use open parentheses because those endpoints are not included. If you want, you can write it as an inequality. -5 is less than x, which is less than 2. Okay, so that's how we solve quadratic inequalities algebraically. So now you can go ahead and pause the video and try doing this example on your own. So here you can see that I solved this by factoring, but you can use your preferred method. You can graph, you can use tables, whatever you want. But you should get the two solutions, x equals 2, x equals -4. Since we have a less than or equal to sign, those endpoints are going to be included. Then I picked a test value in each of these regions. If we plugged in -7, we get that makes the inequality false. If we plug in 0, notice that it does make our inequality true. And if we plug in 5, that makes our inequality false. So the region that's going to be included in our solution is this right here between -4 and 2. And my endpoints are included, so that is square brackets, and I have that interval going from -4 to 2. And that can be written as an inequality, which is -4 less than or equal to x less than or equal to 2. So now let's try this example. We have x minus 2 squared is greater than or equal to 36. So to solve this, I'm going to write the corresponding equation, x minus 2 squared equals 36. Well, here the square term is already isolated, so I can solve by taking the square root of both sides. When I take the square root of both sides, I have x minus 2 equals plus or minus the square root of 36. Well, the square root of 36 is 6, so I have x minus 2 equals plus or minus 6. So I can separate this now into two equations. I have x minus 2 equals 6, x minus 2 equals -6. And we can solve now by adding 2 to both sides, which here it'll give us x equals 8. And then over here, we're going to add 2 to both sides. And so that will give us x equals -4. So since we have a greater than or equal to sign, these endpoints will be included. So I'm going to put a filled in circle at 8 and a filled in circle at -4. So now let's pick a test value in each region. So in this first region, I'm going to use -10. Here I'm going to use 0, and then here let's use 10. Okay, so I'm going to plug into my original inequality now. So if we plug in x equals -10, that's going to give us -10 minus 2 squared greater than or equal to 36. So we have -12 squared greater than or equal to 36, which tells us that 144 is greater than or equal to 36, which is true. Okay, so that means that this region right here is included in our solution. Now let's try x equals 0. So we have 0 minus 2 squared is greater than or equal to 36. So that gives us negative 2 squared is greater than or equal to 36, which is 4 is greater than or equal to 36, which is false. So we don't include that region in our solution. Now let's try x equals 10. So that gives me 10 minus 2 squared is greater than or equal to 36. So 10 minus 2 is 8, so we have 8 squared is greater than or equal to 36, which tells us that 64 is greater than or equal to 36. So that is true. So I'm going to shade in this region right here. So notice now we have two separate pieces included in our solution. And the way we write that in interval form is we're going to say it goes from negative infinity to this endpoint, which is at negative 4, and that negative 4 is included, so I'm going to put a square bracket there. Remember, we use a union symbol now for the second piece. The second piece goes from positive 8 to infinity, so we're going to use that open parentheses with infinity. If we want to write this in inequality form, we're going to say x is less than or equal to negative 4 and x is greater than or equal to 8. Okay, so those are going to be my solutions to this inequality. So now you can go ahead and pause the video and try doing this example on your own. So what we did here is we had to first rearrange in standard form. So we have x squared plus 5x minus 6 is greater than 0. I solved by factoring, but you can use whatever method you like. So that gave us two endpoints, which are x equals 1 and x equals negative 6. I picked a test value in each region. Negative 10 made my inequality true, so I shaded in that region. 0 made my inequality false, so I did not include that region. And then 5 made my inequality true, so I did include that part. So when I wrote this in interval form, that is negative infinity to negative 6. Notice it's not included because in this case I have a greater than sign, so I don't include my endpoints. So we have negative infinity to negative 6 with open parentheses union 1 to infinity with another set of open parentheses. We can write this in inequality form as x is less than negative 6 and x is greater than 1. So you can use the methods we learned when solving quadratic equations to solve quadratic inequalities. Remember to graph the solutions to the equations as points on a number line and then determine which regions are included in the solution set.